Welcome back to Cosmos in a Pod Space and Astronomy series. Have you ever just looked up at the night sky and thought about where it all came from?
Oh, absolutely. I mean, it's amazing, isn't it? All that stuff up there, the Earth, the other planets, even, the atoms that make us.
Right? It's mind-boggling. And the
Yeah.
thing is, the answer, at least part of it, lies in these crazy events called supernovae.
Yeah, supernovae, those huge star explosions. You wouldn't think they'd have much to do with creating things.
Yeah. I mean, they get kind of known for, well, destroying things, right?
That's true, but that's the really cool thing about them. They're both endings and beginnings at the same time. Like, yeah, they destroy a star, but when they do that, they actually scatter the ingredients that you need to make new worlds. I mean, even life itself.
Like a cosmic phoenix or something,
Yeah.
rising from the ashes.
Exactly. So tell me, how do you think a supernova helps with planet formation? What happens during one that's so important?
Well, that's what I'm hoping you can explain.
Okay, well, imagine a star, way bigger than our sun. It's at the end of its life, and it's been fusing elements, lighter ones like hydrogen, into heavier ones. It's been doing that its whole life, building up to iron in its core. But then it runs out of fuel.
Oh, no. So no more energy to keep everything together.
Right, exactly. And when that happens, the core just collapses, under its own gravity, and then
Yeah.
boom, supernova. But it's not just an explosion, it's a wave of energy, a huge amount of energy that spreads through the star. And the important part is, for a short time, just a moment, things get so intense that it can actually create elements that are heavier than iron.
Whoa, wait, so that's where heavier elements come from. Things like what? Like gold or uranium, the stuff we have here on Earth.
Exactly. Think of it like a giant cosmic forge, right? When the star was alive, it could only make elements up to iron through fusion. But a supernova is so powerful that it allows these other processes to happen, things like nucleosynthesis and neutron capture.
Okay, those sound like some complicated science terms. Can you break those down for me a bit?
Sure, nucleosynthesis basically means making new atomic nuclei. And it can happen during a supernova because atoms are smashing into each other super fast under all that pressure. That can fuse them together and make heavier elements.
So it's like a cosmic particle accelerator. What about neutron capture?
That one's a bit different. See, in a supernova, there are tons of neutrons flying around, and some of those neutrons get absorbed by atomic nuclei. So when that happens, the nucleus gets heavier, and that can change it into a whole different element.
Wow, so the atoms are basically grabbing these neutrons and bulking up and becoming something new. Wild. But, okay, how does all this stuff, this new material, how does it get to planets? I mean, the planets aren't forming right next to the supernova.
That's where the scattering comes in. See, the force of the supernova blasts all the stellar material out into space. And remember, that includes all those newly made heavy elements.
Yeah.
And it travels huge distances. We're talking immense distances. It ends up in these giant clouds of gas and dust that are between the stars. Astronomers call it the interstellar medium.
So it's like the supernova is seeding the galaxy, giving it the building blocks to make new planets.
Precisely. And that's not even all of it. This material, it doesn't just float around forever. It eventually clumps together into giant clouds. We call those molecular clouds. And you know what? Those are the birthplaces of new stars and planets.
Oh, so the supernova actually helps start the process of making planets.
You got it. It can even play a role in triggering the formation of new stars and, whole new solar systems.
I'm seeing a theme here.
Yeah.
Sounds like supernovae are some serious cosmic architects.
You could say that. It's not just about getting the ball rolling, though. Supernovae actually contribute to the diversity of planets that we see out there, too.
Oh, okay. What do you mean by diversity?
Well, think about it. Without those heavier elements that supernovae make, we wouldn't have the ingredients for, well, rocky planets like Earth. I mean, you need silicon to make rocks, iron for a planet's core, all those things. And you need heavy elements for the cores of gas giants. That's how they hold on to their thick atmospheres. And of course, well, no heavy elements means no. Us.
So it's all connected. It's kind of blowing my mind a little. It sounds like without supernovae, our solar system might not even exist at all.
It's true. And get this. There's evidence that suggests our own solar system has a connection to supernovae.
Okay, now you've really got me interested. Tell me more.
Okay, well, scientists have actually found traces of these things called short-lived radioactive isotopes, things like aluminum-26 and iron-60, and they found them in these really old meteorites.
Huh. Okay, and what do those tell us?
Well, the thing is, those isotopes don't stick around for very long. I mean, in a cosmic sense, right?
Right.
So the fact that we found them means they must have been created pretty recently. Relatively speaking, of course. And the only place those kinds of isotopes could have been made is in a supernova.
So it's like finding a fingerprint at a crime scene. It proves a supernova was nearby, right?
Yeah. It's like a timestamp telling us a supernova went off right before our solar system began to form. It's pretty cool, right? But there's more. Remember how we talked about supernova shock waves compressing gas clouds?
Yeah, that was amazing.
Well, think about the solar nebula, that cloud of gas and dust that our sun and planets formed from. It was probably, well, most likely given a little kickstart by one of those shock waves.
It's amazing. It's this incredibly destructive force, but it also gives this, I don't know, subtle nudge to start things. It's like a delicate balance.
It really is. The universe is full of paradoxes like that. It's what makes it so fascinating. And speaking of fascinating, think about all the heavy elements we have here on Earth. Iron, gold, uranium.
Yeah.
All of those were created in a supernova billions of years ago.
It's just amazing to me. I mean, something as destructive as a supernova actually created the stuff that makes up, well, everything. The planet, us, even the things we think are valuable and special like gold.
It really highlights how everything in the universe is connected. Destruction and creation are two sides of the same coin. They're both part of the process, Supernovae might destroy stars, but they're also what gives us new worlds and possibly new life.
Yeah. So we've got all this evidence that supernovae played a role in how our solar system formed, but I'm guessing this isn't just something that happened here. It happens all over the galaxy, right?
Oh, yeah, absolutely. Astronomers have looked at protoplanetary disks. Those are the swirling disks of gas and dust where planets form around young stars, and they've found that a lot of them are full of these heavy elements.
And they're coming from supernovae.
Exactly. It's a pretty clear sign that supernovae are shaping planetary systems throughout the galaxy. They're not just local events, they're affecting things on a huge scale. It's like they're these galactic gardeners, scattering seeds for new worlds to grow all across the cosmos.
I like that, galactic gardeners. But, we've talked a lot about the good things supernovae do, but earlier you said that a supernova too close to a planet could be, well, bad news. So how close is too close?
That's a tough one. It depends on a bunch of things, like how big the supernova is, what type it is, what kind of planet we're talking about, if it has a magnetic field, a thick atmosphere, a lot of things. But in general, if a supernova goes off within, say, 50 light years of a planet, things could get pretty bad.
50 light years, that's still incredibly far.
It is huge. I mean, for us, right, but on a galactic scale,
Yeah.
It's not that far. Don't forget, supernovae release massive amounts of energy. We're talking about intense radiation and super powerful shock waves that can travel across huge distances.
What would happen to a planet if a supernova went off that close to it?
Well, it could range from losing its atmosphere to, well, basically getting completely destroyed. Like, imagine a planet with a thin atmosphere, like Mars. That radiation and those shock waves could just blow the whole atmosphere away, leaving it, completely barren and exposed.
Oh, wow. So that's pretty bad. But what about a planet with a thick atmosphere, like Earth? Would it be safe?
Well, not necessarily. It might actually be even worse for a planet like ours. Think about it. All that radiation could cause huge wildfires, destroy the ozone layer, and maybe even boil away the oceans. It would be an apocalypse, basically.
Wow. Okay, I'm officially terrified. I mean, it makes you think about how fragile life is. So how likely is it that a planet will actually get hit by a supernova, though?
Don't worry too much. Supernovae are pretty rare, especially where we are in the Milky Way. They only happen a few times every century in the whole galaxy, on average. So the chances of a planet getting hit directly are pretty small.
Okay, that makes me feel a little better. But I'm guessing there are some places in the galaxy where supernovae happen more often, right?
Yeah, that's true. They're more common in places where stars are actively forming, like in the spiral arms of galaxies. So if you're a planet in one of those areas, your chances of encountering a supernova might be a bit higher.
Interesting. Okay, so even in those areas, a direct hit is still pretty rare, right?
Right. It's more likely that a planet would just experience the side effects, like getting more heavy elements in its protoplanetary disk. It's a delicate balance, Too close and it's a disaster, but at the right distance, it can be the thing that makes life possible.
So it's like walking a tightrope, huh? Destruction and creation, always together.
Exactly. And that brings up another interesting thing about supernovae. What happens to what's left after the explosion, the remnants?
Oh, that's a good question. What has happened to them?
Well, a supernova can leave behind some pretty incredible stuff depending on how massive the star was. We're talking about neutron stars and even black holes.
Wow. Okay, those are not your everyday leftovers.
You're telling me? Imagine this. You take the entire mass of the sun and you squeeze it into a ball just a few miles across. That's a neutron star.
That's crazy dense. What would even happen if you, like, got a little bit of neutron star material?
Well, a teaspoonful would weigh billions of tons. I mean, that's how dense they are. And get this, they spin really fast, so fast that they shoot out these beams of radiation. They sweep across the sky like a lighthouse. That's what we call a pulsar.
So they're tiny, super dense, and spinning like crazy, shooting out beams of energy. It's amazing how the universe works. But what about black holes? I felt like those are even weirder.
Oh yeah, black holes definitely take the weirdness up a notch. They're basically these regions of space-time where gravity is so strong that nothing, not even light, can escape. It's because when the core of a supermassive star collapses, it all gets squeezed into a single point, a
A
singularity.
singularity, infinite density. I don't even know if I could wrap my head around that. And if no light can escape, how do we even know they're there?
Good question. We can't actually see them directly, but we can see how their gravity affects things around them. Like if a star is orbiting a black hole, it'll behave in a certain way so we know something's there.
So they're like these invisible anchors warping space and time around them. Crazy. It's amazing to think that both neutron stars and black holes, these crazy, incredible objects, come from these giant stars dying. It's like the universe is constantly recycling itself, turning energy and matter into something new over and over again.
That's it. That's the key. Nothing is ever really lost, just transformed. That's what makes studying the cosmos so amazing. It's all about this interplay of destruction and creation. Even these huge catastrophic events can lead to something new.
It really puts things into perspective. We started talking about planets, and now we're talking about black holes. It's just,
Yeah.
I don't know, it really makes you think.
It all comes back to that big question, right? Where did it all come from? The Earth, the stuff that makes us, the planets we see. It all started in those supernovae, those incredible cosmic furnaces.
It's one thing to, like, know it, but it's another to really understand it. To realize that every little bit of me, every atom, was once part of a star, forged in a supernova. Even the gold in this ring.
Exactly. We are literally stardust. It's pretty humbling when you think about it, but it's also kind of amazing. It connects us to this huge story that's been going on for billions of years.
Yeah. So I know we have listeners out there who are probably just as fascinated by this as I am. What are some ways they can learn more about supernovae?
Oh, there are tons of resources out there. Books, articles, amazing pictures and videos from Hubble and James Webb. Organizations like NASA and the European Space Agency post updates all the time about new discoveries. And if you want to get really hands-on, there are groups of amateur astronomers who hunt for supernovae. They share tips and work together. It's pretty cool.
So even someone with a telescope in their backyard could help find a supernova.
Absolutely. I mean, some supernovae have actually been discovered by amateur astronomers. It's citizen science, Anyone who loves space can be a part of it.
That's awesome. So to all our listeners out there, keep looking up. You never know what you might find.
And remember, every supernova we observe, every new thing we learn, helps us understand our place in the universe a little bit better.
Well said. I think that about wraps up our deep dive into supernovae and planetary formation. It's been an amazing journey filled with, well, just mind-blowing stuff. What do you think?
I've had a blast. It's been a pleasure exploring this with you.
And for our listeners, if you want to keep learning about the universe with us, make sure to subscribe to Cosmos in a Pod and check out our YouTube channel for more deep dives into the world of space and astronomy.
We're always excited to share our love of the cosmos with you. And who knows what mysteries we'll uncover together next.
Until next time, keep looking up, keep asking questions, and never stop exploring.